Good afternoon, welcome back to the workbench. I have got something a bit different to show you. I have a curve tracer which I've just built. It's based on a magazine project from Silicon Chip, and I want to test some components with it to see what we get. I want to test these specifically. If you've been looking recently, maybe not so recently, but yeah, I had a troubleshooting a DVD player which has this main chip for the switch mode control and the power supply, and it went faulty. It just went dead. It wouldn't start up, wouldn't do anything. And I bought some new ones, or some used ones off AliExpress, replaced one, and it started up and worked. And yeah, it's the STR-X6768 from Sanken, obsolete, so I couldn't really get them from anywhere else. It's one of these sort of like integrated things. It's got the PWM control and everything integrated with the MOSFET as well in a single package. Big TO3P package. Quite convenient, I suppose, for designing, but these things just often seem to die just for no good reason. And yeah, anyway, so I want to test these because in a previous video I tested them. I did some comparisons. I had some chips. I bought the chips. I bought 5 off AliExpress, and I had the one that I pulled out, and I did diode readings on my multimeter between the pins and compared that with the one I took out with the ones I bought, and I found that the readings for the old one that didn't work were exactly the same as like 4 of these ones that I bought, and then one of the ones I bought had different readings, which I didn't use that one because I thought it was probably faulty. I put one of the other ones in and the supply works now, so I don't know what the difference is. We can't tell with diode mode, just comparing voltage drops or resistance between the pins. That doesn't seem to show any difference. It's got the original one here, still stuck to a bit of anti-static bag because it's got heatsink compound all over it, and so this one doesn't work in the circuit. The circuit's just totally dead. It doesn't start up or do anything. And like I said, but the voltage readings on diode mode across all the pins here are like exactly the same as all of these bar one, and including a working one that is now in the supply that works. So that's confusing. Why does that one not work? These all read exactly the same. Hard to tell, right? So I thought, you know, I've got this, I built this curve tracer, and I want to compare them with this because I think this will show more information about what's actually going on. And we can also compare that with the one that had weird readings that didn't match the other two, or the other 4, sorry. And I want to see like how that looks. So yeah, I built this thing here based on this design here from Silicon Chip. It's pretty old, from 1999, but it doesn't need to be particularly complicated, and it has an option to do like transistor measurements. So it has a third terminal with a base step generator, so it's quite useful for that, and it can also be used as just a standard curve tracer as well for like 2 terminal devices like diodes or basically anything really. So yeah, it's quite versatile and useful. It only has 1 channel though, so harder to use for comparing circuits or comparing things, but of course you can still do that just the same way you could do it with a multimeter. It's not impossible. So anyway, so that's the one I've made, and yeah, you can buy the article off them and get the design files and everything. I can't really show that on here because obviously it's copyright, and I can't really give that away for free because it's not my design to give away. So if you want that, you'd have to buy it off the magazine here. But yeah, but it's quite good. I mean, there are other designs around that have the basic concept, you know, this shows the basic sort of thing here. Really, the extra circuitry that they've added is the base step generator and stuff like that. There are designs for like a really basic curve tracer that just does AC. Online, often called an octopus tester, but this is kind of more advanced and has extra features which makes it quite nice, which is why I decided to build that over one of those. Let's have a look and see how it goes. I'll just demonstrate and then we can do some comparisons. So if you've never seen one of these before, it basically just applies like AC waveform to the device under test, although I can change that to be polarized if I want to test like different transistors, but in general you can just use AC mode. So for example, we have a diode bridge here, bridge rectifier, and if I hook this up to here, now we can see we've got a straight line on the oscilloscope, and that's important in this one too. This hooks up to an oscilloscope, so you can't use this by itself. It does require a separate scope, where you can buy curve tracers from AliExpress that have a built-in screen and everything. It's different. So yeah, so a horizontal line is basically open circuit. because we're kind of plotting, I guess, we're plotting current against voltage, basically. Instead of an oscilloscope normally plotting voltage against time, we're plotting sort of voltage against current. So if there's no current, it's a horizontal line. There's no current flow. If we connect the probes together, we get a vertical line which shows all the current because it's a short circuit. And if we take that off, we get a horizontal line for open circuit. So if we connect a diode, for example, you can see something a bit different. We get a sort of an L shape. And that shows sort of the difference between the diode like not conducting and conducting. And I don't know what this little sort of jitter on it is. At the bottom here, where it sort of goes down a little bit, but that could be the recovery time of the diode. It's a bit slow. I mean, this is just like, you know, for AC, low frequency AC from mains, basically. So it could just be the recovery time of the diode, I'm not sure. Just quite slow. If we connect across the AC, obviously we get nothing because it's reverse biased and everything. But yeah, we try the different diode, we get the curve shows differently because we've got the other diode conducting the other way. You know, that shows you a thing. So you get different waveforms depending on what you're probing. So a standard diode junction looks like an L shape. Capacitors look different as well. Looks like a circle. That's not a very good circle because the AC waveform coming out of this is a bit trash. It's derived from the mains, and the mains isn't perfect. Obviously, if you had this, if it had its own internal sine wave generator that was, you know, nice and clean, that would be a much nicer circle. It also could be that this capacitor is just old and crappy as well. I think it's actually just the waveform provided by this is actually not very good. If I change the current, we can see that changes in shape, so you know everything varies with current and stuff. If I change the voltage, it goes a bit different. What I thought was interesting is if you put an LED on it, you get a different sort of waveform altogether. Or at least, well, okay, you get a diode waveform on the low voltage mode, but if you put it on the higher voltage mode, we actually start to see like a sort of a Zener breakdown of the LED at a certain voltage. It's quite interesting. So yeah, that's on the higher voltage range. We can turn that down again so it's not off the screen. But what I'm really interested in doing is actually, like I said, testing these chips. So I'm going to do that. So we have here the one that doesn't work. We also have 3 here that maybe work, which I haven't tested. And I also have one which measured very strangely. Let's start with one that is probably good. Admittedly, this is a bit of a question because I've never tested this one. I've only tested the one that's currently in the DVD player, and obviously that's the only one that I know for sure does work. But let me just have a look at the datasheet again so I can get the pin out. Let's see, so pin 3 is ground. We can test like across ground, I guess. If we set that as ground, for example, and let's test to say pin 7, which is the OCP thing, we get like kind of a semiconductor junction that conducts in 2 different ways on the polarity, and we get that shape there, which looks like a lightning bolt. And if we check pin 6, which is the feedback pin, we get pretty much very similar to the LED that we saw kind of shape. Looks like a kind of a chair shape. And say we test pin 5, we get the same similar thing, but it's got a slightly different shape to it. Pin 4, for example, is just a clean sort of diode shape. Pin 2 is kind of like that, and pin 1 is another diode one. So yeah, I think what's interesting about this is we get these various different waveforms, not waveforms really, but you know, curves, signatures. But let's just say, for example, this one here, we've got like this lightning bolt shape, and we've got this kind of chair shape, let's say. And if I was to compare that with, say, this one, which I know has different readings than the others, if we compare the same pin, we don't get the lightning bolt shape at all. We just get a line. It almost looks vertical, so it almost looks like a short circuit, but it's actually diagonal. If we change the current, you can see it becomes, well, it changes a bit. Remember, this is in like the order of milliamps, so I'm not putting much current into the device at all. But you can see it's like a diagonal line basically, but it's straight mostly. So that's more like a resistor. And yeah, I forgot to actually demonstrate that. I probably should. Here's a resistor. It's 100 ohms, I think. Yeah. If we connect that to the device, we get, well, again, it almost looks like a vertical line. This is a low value resistor, it's only 100 ohms. So if I increase the current, again, we see like a sort of an angle. So yeah, that's kind of different. So if the probes are open, you get a horizontal line, open circuit. Vertical line is a short circuit. And with a resistor, you get a diagonal of some kind, which obviously depends on how much current you're passing through it, because it will change in angle. But I think that's a very important difference between these two chips. As we can see here, like this apparently good one shows this kind of lightning bolt thing, and we can see that looks similar to a kind of a diode junction that's conducting in two different ways, depending on the polarity. But again, if we look at this one, which measured weird with the multimeter, you can see that the same pin, we just get the diagonal line, which shows that this is basically have just turned into a resistor, so there's no actual semiconductor junction there anymore. It's not showing anything up. And yeah, we could see that these two were definitely different. On the multimeter they had different values, markedly different values, but it's actually really interesting to see on here that the difference is in fact that this has no semiconductor signature at all. There's no shape of a junction there whatsoever. It's just a line. So this thing's basically turned into a resistor. The junction is no longer there. That's why it's junk, basically. You can see I've put little question marks on it, perhaps. So yeah, like this thing's clearly faulty. There'd be no sense in trying this. We can even try the other pin, the one that showed the kind of chair shape, what I called that. And again, we get a completely different shape. We get kind of a semiconductor junction shape, but it's nowhere near the same as the other one. For example, this one looks kind of like a squashed lightning bolt, or I don't know, a kind of a sort of a thing. You can see what it looks like. And again, if we go back to this one, pin 6, we get a very different shape. So it shows that there's definitely a big difference. And you would expect, if these chips are working and they're all the same, that the signature should be very similar. It should not be markedly different the way that it is. So you can clearly see how this one is definitely different to that one. And I'm pretty sure this is faulty. But what is interesting, what I'd like to see here, is this one, because this one does not work in the circuit at all. So I want to compare that with this one. It would be better obviously to pull the working one back out of the supply and actually compare it, because we know that one functions. I don't know if this one functions, but it reads the same as the one that I did put in. It also reads the same as this, which is the confusing part. So what I want to do is check it with these, test it with this, and see what happens, if we see any differences. So let's try that. So let's go back to ground. Doesn't really matter actually which pin we test to which, but there we go. We've got our sort of lightning bolt shape on pin 7, and from 3 to 7, and if we test this one, which doesn't work, well, let's see what we get here. Do we get something similar, or do we get something entirely different? I don't know. Well, we do get a lightning bolt shape there that looks pretty much exactly the same. So that's interesting. Let's try the chair one. We do get pretty much exactly the same there. Okay, what about pin 5? Let's check pin 5 on the probably good one. And we get a kind of a chair shape, but it's a little bit sort of distorted. So let's try and see what this one does. Well, yeah, that looks pretty much the same as well. What do we get on pin 4? This one shows a diode junction. And I think this one showed the same thing. Yeah, it does. So this is interesting. All these curves are coming out basically the same. We can check pin 2. We get a diode with kind of an angled base. If we try that on here, let's see, that's on pin 2. Yeah, we get the same thing. And what do we get to pin 1? Just a diode. And on this one, we also get a diode. Okay, well that's interesting, and that's very confusing because we get literally the exact same reading between this one and that one again. So why doesn't this one work in the circuit? Is there something else wrong with it that maybe I'm testing the wrong pin combination? Maybe I should try between VCC and other things. Let me try, let's see, so pin 4 is VCC. So if we check between pin 4 and say ground, we'll get, well, yeah, the exact same thing, except now it's around the other way. Because we've got the probes around the other way. Okay, from VCC to pin 1 is open, which it probably should be because that's the drain of the MOSFET, so I wouldn't expect that to be connected internally. To the source pin, we get this kind of little shape. So let's compare that with this one. So we're looking at pin 4. Pin 1 is open circuit, yep. And pin 2, which is the source of the MOSFET, we get the same little curve. So let's see, to pin 3 we get that. It's going to be the same because we tested those pins together before. Let's try pins 5, 6 and 7. So pin 5, we get this kind of little strange sort of shape. To pin 6 we get a diode shape, and to pin 7 we get that shape. Okay, so let's compare that to here. Yeah, pin 5 we get this shape, pin 6 we get that shape, and pin 7 we get the diode shape. So that's all exactly the same actually. So now I'm even more confused. I'm really not sure what to say then, because unless these two are both dead, of course. I do have 2 more here that we could do a quick test with. Pin 5, yeah, the little wonky sort of thing. Pin 6, that shape. Pin 7, that shape, yeah, it's pretty much the same. That one there's got the same shape. That one there's got the same shape, and that's got the same shape. So, yeah, I mean the only one that actually looks any different is this one, where it would appear that some of the junctions have turned into resistors basically. So I'd say this one's definitely bad. We know that this one seems to test exactly the same, both on the curve tracer and with the diode mode on the multimeter, and yet this one does not work in the circuit. It just doesn't turn on, which I find very fascinating and also confusing. I genuinely thought that this would show some kind of difference, that there'd be something obviously going on. I wonder if it's just something internal to the chip, perhaps, that, you know, maybe the gate of the MOSFET is open circuit, and obviously that's isolated from the outside pins. If we look at the datasheet again, you know, we've got the drain, source, the MOSFET. The gate has an internal connection. Whoops, where's my cursor? There we go, we've got the drain, source of the MOSFET. The gate has an internal connection to here, which, you know, obviously the gate is meant to be isolated, so you wouldn't see, you shouldn't see anything there. If there was some fault in the gate drive circuit, yeah, I guess, yeah, I suppose whatever fault is with that chip, or at least it appears to be faulty, it's some internal thing that cannot be measured on the external pins. I do wonder if we test just directly across the MOSFET and see what that comes up with. But I don't think that will prove anything. Again, we've got like a diode because we've got the reverse diode thing. We can change the voltage, but it doesn't do anything. You wouldn't expect to. I mean, that just looks like a MOSFET that's not bad. It's not shorted or anything. And again, if we try one of these ones, I think we'll get the exact same thing, which we do. So, you know, there's no sort of evidence here really there's anything wrong. So I guess the conclusion is that, yeah, I mean, for some chips you just cannot seem to be able to tell externally with testing, even with something like this, that there's anything wrong. I don't understand. Does anyone else understand? Because I don't. All I can think of again is that there's just some internal thing. There's some internal connection in here that has failed. Some part of the circuit has failed inside, and it's not measurable but on the external connections. And those will show normally, but you know, something internal has failed. And there's no way of telling except for just powering it up, and it just doesn't work. So yeah, that's interesting. Kind of annoying. There's no real apparent diagnostic ability to sort of verify this except for just changing it for a new one, which I suppose is, you know, not that difficult. But I would have liked to sort of come up with a conclusive thing that shows, you know, this is actually different to these other ones, and it definitely doesn't work, and this is why, you know, we see a different signature, a different curve between particular pins, but no, they all seem to be identical, so that's interesting. Not what I expected. Not what I expected at all. I did, of course, this dodgy one. That is interesting to see what this had. You know, we have pins where normally you'd see a semiconductor junction of some kind on these ones, just showing up as a resistor basically in this. So you can say, I'd say for sure this one is definitely bad. There's definitely some issue within it. Whether that's ESD damage or something else, I don't know. The thing obviously hasn't exploded. It's, you know, the casing looks fine. I don't think this is a blown part. It's just sort of obviously silently failed as well, maybe just like this one, but this one does have visible signs externally that there's something wrong, whereas this one apparently doesn't. So yeah, I guess with some faults the only way to test if something is bad is just to replace it with a new one, and use that to prove that you've got an issue or not. So even apparently with a curve tracer you can't figure it out, which I think is quite interesting. So that begs the question, you know, there are usage scenarios of these curve tracers, and famously a product called the Huntron Tracker, which can be used to compare two circuits. So I am quite interested in the concept of that. You know, if you had a power supply with this exact chip in it, and a good working power supply you were comparing to, I feel like you would not actually see any difference on the board, because this doesn't show any difference as a component itself. So, you know, you probably wouldn't be able to find the fault that way, even though in many situations you can, because as you saw with this one, the signatures do show up markedly different. But apparently with this it's not the case, and obviously I don't have an identical power supply to compare to. So yeah, so that's quite interesting, quite fascinating. Yeah, I didn't expect that result, but that's an interesting result nonetheless. I guess, you know, that's still more information that goes to show that, yeah, sometimes you can't find the fault with test equipment. It's just outright replace the chip, and that's the only way to go. So good to know that even this isn't perfect. I should still find this to be quite useful, I think, in a lot of situations, for doing comparisons and stuff, and also for, you know, testing transistors and comparing them as well. I think this could be quite useful to help find fake transistors potentially, get different curves out of, you know, different things. I might do a video testing transistors with this at some point. or something else, but you know, I just wanted to show the kind of basic operation and the basic idea, and I just wanted to, just out of interest, I wanted to see if there's any appreciable difference with these, and apparently there isn't. So, except for the sole fact that this doesn't work, unless these three are all dead as well. I suppose for conclusivity's sake it would make sense to pull the known working one back out of the power supply and compare that to this one, but I don't think that that's really going to show any difference. I imagine it's just going to look exactly the same because it looked exactly the same on the multimeter. I don't think it's going to look any different on this. I think there's something just internal that we can't measure from the outside. I think that's really what's happened. Something internal has failed. Probably something's gone open circuit within the chip, and we can't measure it between any of the outside pins. But there we go. So hopefully that was interesting. Hopefully that was useful. I don't know how useful it is, except to tell you that, you know, sometimes your test equipment will not help you, and that part swapping is the only thing you can do in some cases, it would appear. So yeah, there we go. That's that. See you next time.